Okay, so now we're going to be doing some Dfa proofs. We've got a Dfa here. We're given that this Dfa recognizes the following language over the alphabet ABC. We need to prove for all strings of only A's and B's from the starting state, if I read a C and then alpha and then another C, I'll end up in a final state. I can rewrite this as is equal to S2 because S2 is the only such final state. Okay, so how am I going to prove this? I'm going to prove this by induction on the length of alpha. Okay, so prove by induction on length of alpha. So basically, if you assume it's true for a string of length n, then you prove it's true for a string of length n plus 1, which is going to be built out of a string of length n, so that's how the induction hypothesis will kick in. So our base case is where the length of alpha is 0. So that is, alpha is the empty string. So we have to prove from the starting state, if I read C epsilon C, so that's just two C's, I end up in a final state. So if I'm in S0 and I read C, I go to S1. And then if I read another C, I go to S2. And that's it. And S2 is a final state, so cool, that checks out. Okay, so step case. One way we can do string induction is we assume it works for alpha and then prove it works for any string that's the same as alpha with an extra character tacked on the front. So we will assume n star S0 C alpha C is in a final state, and then we will prove for all x in the set AB, because we're proving this for all strings alpha that are made of A's and B's, n star S0 C x alpha C is in a final state. Okay, so we'll do that. So C x alpha C. So what can I do here? Well, I read a C, I go to S1, okay? So that gets me to x alpha C. And now I guess I have to do cases depending what x is. Well, actually it doesn't matter whether x is A or B. In both cases, I will transition back. Sorry, that should be S1, my apologies. In either case, regardless of the value of x, I'm actually going to go straight back to S1. So I can write that in, S1 alpha C. My justification is because S1 under an A transitions to S1, and S1 under a B also transitions to S1, so it doesn't actually matter what the value of x is. So in either case, it works. Okay, so now what am I going to do? Somehow, I'm going to have to use my inductive hypothesis here, but it's not quite of the right form. But there's another way we could do this. I could rewrite my inductive hypothesis. So if n star S0 C alpha C is in a final state, then clearly I could just read in the first character and find that alpha C is also in a final state. And then I could use this property to help me. So that gets me what I want, right? So then this thing is in a final state by inductive hypothesis, and there's justification over here. So the inductive hypothesis can't quite be applied, but a slight modification of it can. And that's all there is to it. So we proved it for the base case. I assumed it worked for some string and then proved it worked for the same string with a character tacked on the front. Therefore, for all alpha, all strings alpha that are made of just A's and B's, it's the case that from the starting state, reading C alpha C gets me into a final state.